Okay, in this next example, I'm going to show you how to do an excitation ratio. This is very useful for excitation shifted probes or combination of probes where you need multi-excitation wavelengths. We're going to excite at 260 and 290 nanometers, and we'll look at the emission over here at 340 nanometers. So we'll want to open up our acquisition setup, and we're going to select an excitation ratio as the scan type. This scan type is very similar. They're easy to be confused. Notice the color of this one is blue for excitation, and this one is red for emission. Now we can go to the acquisition settings and we can enter those values we wanted to excite at. 260, 290, and we'll look at the emission at 340 nanometers. We're going to enter an integration time of 0.1 seconds, and I'll just continue the scan for 30 seconds. Next thing I want to show you is the traces. We'll go over and we're going to create a derived trace that will create a ratio between these two traces. So simply say add, and we'll relabel this one ratio. Source 1 will be 260. We're going to choose ratio 2 to create an interleaved ratio, and source 2 will be our 290 nanometer. We're going to show the results in graph 2, and this time I'm going to assign them all to the same group. I'm just going to call this group A. This will differ slightly by creating a single group that 3 traces will be contained in. The previous example was a little bit different, where we chose ratio. Each one was contained within its own group. We're going to make sure the system creates a new session. We'll say accept and start. Right, now I'll just show you the tree structure here. You can see we've got group A containing all 3 traces, whereas the previous experiment we had 3 separate groups with the trace within each group. I prefer it this way as the clarity is a little bit better. You can have the 3 traces into one group, which doesn't generate so many trees. Just helps keep it simpler. Okay, you can see here our ratio is averaging about 0.345, and what we'll do next is save this data here. We can rename it first. Let's call this EXC ratio for excitation ratio, and I can save this as a separate session individually if I choose save session as, or I can also choose to include it in the entire protocols that I've done, the entire set of experiments so far, by choosing save record as, and that will contain all scans, which will be everything in the legend. That's how they differ. By right-clicking on a tree, you can save the sessions individually, and by choosing save record as, you'll save everything in the legend into a single trace.